Hello, everybody. Today we'll talk two lectures. I will repeat chapter 8, which is an extra chapter in the syllabus, and it's very, very, very important. I call it a multiplexer. Okay. Before defining what is multiplexer, we have something we need to talk about some background of arithmetic logic unit, combinational logic circuit, sequential logic circuit, what is transmission gate, then talking about what is multiplexer. Okay, so I will repeat the last lecture very fast here as a background, then I will stop here. So what is ALU? Arithmetic logic unit. It is a combinational digital electronic circuit that performs arithmetic and operation on binary numbers, which is كل شيء جمع طرح ضرب اوكي بيكون بقلب الاي ال يو بقلب السي بي يو. اوكي هي it is the fundamental building block of many types of computing circuit. هي الاساس. ALU هو الاساس. مثل بقلب السي بي يو Central Processing Unit, Graphics Processing Unit. Here now the new VGA graphic cards has built-in graphics processing unit similar to Central Processing Unit. So in each newest latest gaming VGA, in the gaming VGA they have microcontrollers. They have CPU, RAM, a memory called VRAM. Memory inside the VGA called VGA RAM, VRAM, has motherboard, CPU, internal ALU, internal memory, everything, fans and everything. So this is called GPU. So the gaming VGA has a mini computer inside it. Okay. What is the operations that ALU perform? The operations, the basic operations are the logic gates, not NAND, AND, NOR, or XOR, or XNOR. Okay. As a fast review, logic gates have n inputs and one output. So logic gates will be an input, one output. Okay. We have here special word called unary operators or unary function, have one input, one output circuit. So if a gate has one input, one output, called unary operator or unary function, similar to or like to inverter. Okay, inverter, one input, one output. Now, what is combinational logic circuit? The word combinational comes from word combine. This circuit combine different logic gates in the circuit. So if we put and or NOR, XOR, not whatever, 2 or 3 logic gates in the same circuit, we call it combinational circuit. Example: encoder, decoder, multiplexer, demultiplexer, half adder, full adder, multiplier, and so on and so on and so on. So these circuits has inside it or contains many logic gates, different logic gates. Okay, this is called combinational logic circuit. Okay, so in another course you will take this in logic design, the multiplexer, the half adder, full adder, and multiplier. Today we'll talk only about multiplexer. Okay, they have an input and m output. So any circuit that has an input and m output and contains different logic gates called combinational circuit. Okay. The output at any time or instant of time depends only on the input, not on the time. It's not time dependent. It's time independent logic. So no time here. We don't have memory. We don't have time. We don't store any information. For different input, we have different outputs. This is what is combinational circuit. Okay. Whereas sequential circuit, logic circuit, has memory. So the output can vary based on at the same time if the input is vary and what is inside the memory. So the output will depend on the input and on the memory element. So now we have time dependent circuit. Example, flip-flops, registers, counters, and memories. So here in this circuit, in this sequential circuit, we store data. Here we have storage area, memory element. So also, of course, in any circuit, in any digital circuit, always we have combinational logic circuit. Always we have. If we add something called memory element or else to store anything, this whole circuit will become called sequential circuit. Okay? For here, any question?
No, doctor.
Good. Now, as a fast definition, what is the digital registers? The registers, it is a 1-bit memory cell called flip-flops. Okay, this register, it's flip-flops. It's 1-bit memory cell, which can be used for storing the digital data. Okay, so in another course in logic design or logic system, you will talk this in details. So inside the memory, we have something called flip-flops. Today, or in this course, we will not talk about, just a define. So to increase the storage capacity in terms of number of bits, we have to use a group of flip-flops. Okay, each flip-flop has 1 bit. I want 16 bit, so I need 16 flip-flops. Okay. Okay. Now, another something. Okay. There is something called the pass transistor logic gate, PTL, pass transistor logic gate, PTL, which is only one transistor. But this transistor will be used in different way. This transistor will be always on or off if you want, but we have here instead VDD always 5 volt. Here we put our signal, our input signal, and we take it from here, the output from drain, gate, source. So in MOSFET or CMOS, okay, we replace the VDD, the drain here, the VDD by input signal. This input signal will be variable, will change the input from 0 to 1, from low to high or high to low. So now the drain will be used as input gate, and the output from source here, and we'll see the output, what will happen, if output equal input or no. So this is small one transistor called pass transistor logic. Here in this transistor, it's NMOS transistor or NCMOS transistor, okay? Or N MOSFET, N channel. Here we have N channel. For N channel, MOSFET or CMOS, if the gate voltage is high, the transistor will be on, else will be off. So to connect the drain to the source terminals, or to connect or to transfer the input signal to the output signal, we need to activate or turn on this transistor. Okay, so here, if the input is 0, low voltage, okay, so here the input is 0, always the transistor is on, always on. If the input is 0, then the output will be 0. The 0 will be transferred from here to here, but still 0 volt. So 0 volt will end by 0 volt. This is strong 0. But we will review the golden rule of CMOS technology about that. Always the N MOSFET or N CMOS, we connect it to the ground to be strong. If we connected the N MOSFET or N CMOS to the voltage power supply, so the internal diodes inside the transistor will be turned on and will get weak result, not strong result. So again, the golden rule of CMOS technology said always connect N channel to the ground and connect P channel to the power supply VDD to get strong output or input, whatever. Okay, so here this is N channel. If we put input as high, 5 volt, the output will be 4.5 volt, will not be 5 volt. So it's weak 1. So 0 will give us strong 0, 1 will give us weak 1. So here we have internal diodes inside it. Okay, 0.5 volt will be decreased from 5 volt. So 5 minus 0.5 give us 4.0. But 0 will not decrease 0.5. Okay, will not go deeply inside the transistor. Why this is happen? Okay, it's similar to BGT transistor or something like that. We have internal diodes. If the input is 0, no internal diodes has effect or something like that. If the input here is on the drain, here input is the drain, high voltage, okay, so the internal diodes will be activated by many equations. Okay, we don't know what is, we will not know what is, okay, because it's for electronic engineer. Okay, so we have 4.5 volt as output, okay, called weak 1. So this is disadvantage in digital electronics, but it's not disadvantage in communication or analog circuit or for antenna or for power circuit. For power circuit, 0.5 volt, it's nothing. It's nothing, okay? But in digital circuit will be affected the circuit, okay? So in digital circuit, it is a disadvantage. Now, also, we can replace the N channel by P channel. This is P channel. So P channel, okay, if we put on the gate 0 volt or low, this P channel, P transistor will turned on, else will be turned off. So here, the golden rule of the CMOS technology said P channel must be always connected to the VDD, to the power supply. So if the input is high, the output will be always high, strong 1. So if the input here high, 5 volt, the output will be strong 1, 5 volt also. But if the input is low, we got weak 0. Weak 0 here is equal 0.5 volt. So the internal diode will turn on in our opposite direction to give us 0.5 volt. So if we use PTL logic gates, PTL gate, okay, if you use PTL gate, so we get weak signal and strong signals, but it's not good for our digital electronic circuit. That's why we combine them together. Okay, and something called transmission gate. So to avoid the weakness of each one, to avoid the weakness 1 for N channel and weakness 0 for P channel, we put it in parallel to get N channel and P channel at the same time in parallel, and at the same time will be worked on, will be turned on. So both transistors must be together turned on or together turned off, else we return to this state. We get weak signal. To get strong signal, we need to activate the two transistors, P channel and N channel, together to be on or to be off. Okay, so here we have for 0 strong 0, for 1 strong 1. Okay, and this is called transmission gate. Okay, any question?
No, doctor.
Perfect. We have different symbol of transmission gate. This is only as symbols. Okay, now we replace the VDD 0 volt by a variable called control signal. So here we have C, control signal. Always we have C bar or C bar. We don't care where it is C, where it's C bar. Okay, it can be from N channel C, for P channel C bar, or else from P channel can be C and from N channel can be C bar. So it must be at the same time opposite of each other. So C bar, it's opposite of C. To let the two transistors to be on or to be off together. Okay, so now we have something like this. For C equal to 1, here for C high voltage, N channel will be on, C0 will be 0, so P channel will be on. So this transmission gate, the two transistors, the transmission gate will be on. So for C equal to 1, both transistors will be on. Okay, so always output equal input as a strong signal, 0 0 1 1. But if the C is C equal to 0, C bar equal to 1, so both transistors will be off. Both transistors will be off, so the transmission gate will be off. So the output wire will not be connected to the input wire. So it's an open circuit here. It's on the air. The output wire will be on the air. We call it high impedance. High impedance, Z. High impedance means sometimes this high impedance considered as 1 and sometimes considered as 0. So this state called high impedance, or don't care, or not don't care, sorry, we don't know, unknown state. It's unknown state. High impedance, it's a wire in the air. We don't know what will affect this wire. If there's interference with another wires, it can be considered as 1. If no interference, can be considered as 0. I don't know. So we don't know what it is. Okay, called Z, high impedance. So this is disadvantage. This is disadvantage. We must avoid this high impedance to get strong design. To avoid this high impedance and using transmission gate, if you use transmission gate to avoid high impedance, we need to implement something else. Okay, we'll see it in multiplex. So till now, any question?
No, doctor.
Perfect. Let's begin. What is multiplexer? Now, a multiplexer abbreviated by MUX, MUX, can select between several analog or digital input signals and forward it to a single output line. It can be many input, one output. Example now will be 2-1 multiplexer. 2-1 multiplexer. 2-1 multiplexer consists of two inputs, example W0 and W1. Okay, one output. Okay, 2 power 1. We have two input, 2 power 1. Sorry. Two inputs, one select input S, selection as selection, and one output. So here we have similar to 3 inputs. 2 inputs, W0, W1, and another third input is selection S. The number of selection will be 2 power 1. If we have
2 bit
هون عندنا 1 selection. اوكي كيف نحسبها؟ عندنا 2 input. اوكي 2 input 2 power 1 2 input and 2 power 1. هيدي ال1 الديجيت هون ال1 هي عندنا 1 اس. number of اس كم اس عندنا بالمالتيبلكسر depend on the inputs. اذا عندنا 4 input، اذا في 4 input للمالتيبلكسر بده يكون في عندنا 2 selection line selection input، بده يكون عندنا 2 selection. هلا حنشوفها later on. okay so depends on the select signal هي الاس. the output is connected to either of the inputs. Example here. This is the symbol of multiplexer. Okay, this is the block diagram of the multiplexer. We have 2 inputs, W0, W1. Okay, we have here S as selection input, called selection input, and one output as F. If S equal to 0, then the output will be equal to W0. If S equal to 1, then the output F equal to W1. So here we have selection. This is called the multiplexer. Multiplexer, it is multi-selection, called multi-selection, to only transfer many signals to one output signal. So here depend on the S. If S equal to 0, then let W0 go out to be F. Else, if S equal 1, stop here, stop this line and connect W1 to F. So we have something inside multiplexer as a switching. We have here switch. If S equal to 0, switch this internal circuit to W0 to be connected to F. If S equal to 1, switch the internal circuit that connect W1 to F. Okay, this is called multiplexer. This multiplexer will be used and till now used in communication circuit, in telephone switching circuit, in mobile switching circuit, or telephone switching circuit. Okay, we have multiplexer there. Here we have, if S equal to 0, the output will be equal with W0. If S equal to 1, the output will be equal to W1. It's selection. So the Boolean algebra equation will be equal F equal W0 times S bar, because S is 0, plus here plus it's OR, times here it's AND. We have AND gate and we have OR gate and we have here AND gate. So we have 2 AND, 1 OR. So W0 times S bar plus W1 times S, because 1. Okay, now I will stop here. Who will not take the other course called logic system or logic design or whatever about the Boolean equation algebra?
قصدك دكتور مين ما اخده؟
ايه كلكم اخذتوه؟
دكتور انا ما اخذته.
بس دكتور شو اسمه الكورس؟
دي اس 2 دي اس 1 عفوا.
دي اس 1 دكتور المفروض كلنا اخذناه.
اخذتوه
انا
كلكم؟
هلا عم باخده.
عم بمزح.
اوكي طيب يلي بعد ما اخذ حنعمل ريفيو شو معناتها هيدي الايكويشن او بولين الجبرا، شو معناتها، كيف حولنا هيدا الترو ستيبل، كيف حولنا ترو ستيبل لايكويشن. اوكي هناخذ اكزامبل ليتر اون، والامتحان الفاينل حيكون انكلود وحده منهم. اوكي بس انا حهين عليكم بالفاينل لان البعض منكم مش ماخذ اللوجيك سيستم او ديجيتال سيستم 1 اور 2 وات ايفر. اوكي حاعطيكم جيفن ايكويشن وانتم ترسموا السيركت، من الايكويشن ترسموا السيركت. اوكي ما تخافوا، هالسيشنات حنشتغل فيهم، حنعطيكم كذا اكزامبل حتفهموا البيزكس، ما حنجيب ايكويشنز عجيبه غريبه. اوكي ف عندنا ترو ستيبل، من الترو ستيبل كيف بنطلع الايكويشن. اوكي مين بيساعدنا؟ يلا علي يلي ماخذ ديجيتال سيستم، مين بيقول لنا كيف طلعت الايكويشن؟
اوكي نحن عندنا انه لما s equal 0 اوكي بدنا يكون الاوتبوت w0. هلا
صح.
طالما الاس equal 0 يعني عندنا s بار، كل شيء 0 يعني بار فوقه، 1 بيكون الاس عادي. اوكي لما نحن بدنا نحكي عن الانبوت والاوتبوت مع بعض يعني اس واف، بنعمل اند جيت اللي هو الدوت هون، يعني w0 اند اس بار، الاس بار لانه في 0 والدبليو 0 لانه هو الاوتبوت تاع الاس. الاور لما نكون عم نحكي عن شيء ثاني يعني تحته، كل شيء تحت بعض بيكون الاور، فبيكون w1 اند اس كمان.
اوكي برافو. مين معي؟
علي كوك.
اوكي علي حط بونس، برافو. حزيد عليها شوي. اوكي هلا ما حفوت ديتيلز 100% بس حشرح لكم اياها كيف تنحسب. اوكي بغير اكزامبل حتكون اوضح من هيدا، اوضح من هذا الاكزامبل، باكزامبل ثاني حتكون اوضح، بس هلا حنشرحها بطريقه ثانيه. اوكي كل رو بترو ستيبل، كل رو هون عندنا انبوت اوتبوت. اوكي كل رو هون عندنا 1 انبوت و1 اوتبوت. اوكي سوري عندنا انبوت W0 W1، عندنا سelection هون. اوكي هون سelection وعندنا الاوتبوت، اذا سelection 0 الاوتبوت ايكوال W0. فعاده كل رو لحاله، اوكي كل رو لحاله بناخده از ضرب، نضرب الكولومز على طول، نضرب الكولومز. الضرب يعني اند، نعمل اند، الضرب هون اند. وكل رو يعني او، الاس بتكون يا فوق يا تحت، او الاور ساين هي بلس. فعندنا تو روز بيكون عندنا تو تيرمز، اوكي بيناتهم لانه تو روز وي هاف اور. هذه البلس هي اور جيت، اور ياها يعني يا هيدي بتكون اون يا بتكون هيدي شغاله منا زيرو، ياها بتكون منا زيرو. ف هون حسنات الاس 0 اس 1 اللي هي اس بار اللي قال عنها علي، انه لما يكون اس 0 نحن اذا اس 0 بدنا الدبليو 0، بدنا هيدي، بدنا يطلع الاوتبوت دبليو 0، فبنحط نحن 0 بنحوله ل 1 لنحول 0 ل 1 نحط له بار. ف for s equal to 0 هيدي الايكويشن جيفن، for s equal to 0 شو بصير هون؟ s equal to 0 بار هي 1 and w0 give us w0 plus حنكفي for s equal to 0 بعدنا بزيرو هون 0 and anything، so 0 and anything will be 0، so we have هون الاوتبوت صار عندنا equal w0 plus 0 equal w0. بالطريقه الثانيه if s equal to 1 s bar will be 0 times حيلا شيء 0. اوكي هون s equal to 1 الاوتبوت طلع w1، فهيدي بسموها بوليان ايكويشن. اوكي هناخد اكزامبل ثاني نشرح لكم اياها على الانبوت اوتبوت. هون بهالكيس هون ما في انبوت اوتبوت، هون في سelection واوتبوت ودخلنا دبليو، فهي معقده شوي غير الطريقه يلي انتم معودين عليها. اوكي، بعدين ناخذ اكزامبل ثاني تفهموها اكثر كيف طلعت الايكويشن. ماشي، هي لوجيك ايكويشن بس لوجيك. واضح؟ طيب بالامتحان حتوفر عليكم، ما راح اطلعكم، ما حاسالكم سؤال عندكم ترو ستيبل اعطيني ايكويشن، ما حاجيب السؤال. هذا السؤال بغير كورس يلي بنصكم مش اخذوا بعد او هلا عم تاخذوه، فما حفوتكم بهيدي القصه. حاعطيكم جيفن ايكويشن، من جيفن ايكويشن طلع ترو ستيبل وطلع سيركت، حنمشي بالقلب يلي هي اسهل بالنسبه لكم. اوكي، حناخذ اكزامبلز هلا. طيب
يعني دكتور شلت لنا السؤال السهل.
طيب ماشي يمكن. طيب تنعمل
دكتور يا
ديزاين.
عالم نرجع نفوت دغري عشان هذا السؤال.
ايه بنظهر اذا بدك تاخذ 5 دقائق بدك تعملوا ريست 5 minutes يلا حنفوت دغري ورا. يلا اوكي، so we'll go out right now. اوكي